Welcome students. I am Swati Shinde. Today we will study an interesting chapter of Science Paper 1. I know you all are very eager to know the chapter name. So, this is our chapter Space Missions. Before we begin to the lesson, we just discussed learning objectives and keywords of today's topic. First, space missions, its need and importance. Satellite and its types. Artificial satellite and its classification based on the function. And orbits of artificial satellites. Now we will recall some terms which we have learned in previous standards. Difference between sky and space. The sky is the region in which sunlight is scattered in the Earth's atmosphere and making it visible from the surface of the planet. And the space is everything beyond that, which is outside the Earth and not affected by the Earth. We have learned that there are different objects like sun, planets, dwarf planets, moons, asteroids, comets, and artificial satellite in the solar system. But still there is a question, why do we want to go in space? And the reasons are to explore universe, to see Earth from the space, to examine various heavenly bodies, and to see extraterrestrial life from the space. What is a space mission? A journey by a manned or unmanned vehicle into space for specific reason is called space mission. There are two types of space missions. First, satellite around the Earth, which is used for research and various other useful applications. And the second, spacecraft away from the Earth, which is used for close observations and understanding of the objects in solar system or even outside the solar system. Why do we need these space missions? We need these space missions to our communication, where satellite helps to communicate with each other. Without satellite, mobile networking is not possible. Next is entertainment. For example, dish services. We can watch live cricket matches going in any part of the world by sitting at home with the help of artificial satellite. Next is observation. To watch various planets and understand various objects in solar system or even outside the solar system. And the last is surveillance, where the specific country watch itself to check whether there is no enemy action. Let's have a look on history of manned missions. The first person to go into the space in spacecraft was Yuri Gagarin of the USSR. He orbited the Earth in 1961. Then the first person to step on the moon in 1969 was Neil Armstrong of USA. After that, Rakesh Sharma of India orbited the Earth in 1984 in a Russian spacecraft. After that, Kalpana Chawla and Sunita Williams of Indian origin also participated in space explorations through missions organized by NASA of USA. Let's talk more about satellite, an artificial body placed around the orbit of the Earth or other planet in order to collect information or for communication. There are two types of satellites. First, natural satellite. A natural satellite is an astronomical object orbiting the Earth or any other planet. Moon is the only natural satellite of the Earth. Artificial satellite. If a man-made objects revolve around the Earth or any other planet in a fixed orbit is called an artificial satellite. Sputnik was the first artificial satellite set into space by Soviet Union in 1957. After that, many nations successfully set their artificial satellites, including satellites like INSAT series by India. These satellites are sent into space to perform various functions. Based on these functions, there are different types of artificial satellites. First type is weather satellite, which is used to study the weather and make predictions about future weather. Next is communication satellite, which is used to establish communication between different parts of the world. Next is broadcast satellite, which is used to telecast television programs. Next is navigation satellite, used to fix the location of any place on the Earth's surface. Next is military satellite, which is used to collect information for security aspects. And the last is Earth observation satellite, used to study of forest, deserts, oceans, polar ice on the Earth's surface, exploration and management of natural resources, observation and guidance in case of natural calamities. Our next topic is orbits of artificial satellite. All artificial satellites do not revolve in similar orbits around the Earth. The functions of the satellite decides the height of the satellites from the Earth's surface, the nature of the orbit, whether it is circular or elliptical, and the third, the orbit shall be parallel to the equator or making some angle with it. To put the satellite in its proper orbit above the Earth's surface, the satellite is taken to the specific height using a satellite launcher. Then the satellite is given a specific velocity known as the critical velocity in a tangential direction to the orbit. The satellite then starts revolving around the Earth. Let's derive the formula for critical velocity. If a satellite of mass m is revolving around the Earth in an orbit of height h from the surface of the Earth with speed vc, then, as seen in the chapter on gravitation, a centripetal force, that is mvc square upon r, will act on it. Here, r is the orbital radius of the satellite from the center of the Earth and is equal to capital R plus h. You can observe the figure for this. The centripetal force is provided by the gravity of the Earth. Therefore, centripetal force is equal to gravitational force between Earth and the satellite. Here we'll get mvc square upon r plus h is equal to capital G capital M small m upon r plus h whole square. By rearranging the equation, vc square is equal to gm upon r plus h. By taking the square root, vc is equal to square root of gm upon r plus h, where g, capital G, is equal to gravitational constant, which is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. Capital M is the mass of the earth, which is equal to 6 into 10 raised to 24 kg. Capital R is equal to radius of the earth, which is equal to 6.4 into 10 raised to 6 meter, which is 6400 kilometer. Small h is equal to height of the satellite above Earth's surface, and small r is equal to capital R plus h is equal to radius of the orbit of satellite. So here we got the formula for critical velocity. As the height of the satellite's orbit from the Earth's surface increases, the critical velocity decreases. It can be seen that the critical velocity does not depend on the mass of the satellite. It depends upon the height of the satellite. So students, let's have a quick revision what we have done today. We have learned need and importance of space mission, satellite and its types, and different types of artificial satellites based on its function, and we derived formula for finding the critical velocity. But how do these artificial satellites reach their orbit? Now that's an interesting question. Let's find out about it. Thank you very much.